Now moving on to question 6. A flat end of a uniform cylinder of weight 7.8 newtons. So we have the force there. The cylinder hangs vertically. The breaking stress for the glue is 130 kilopascal. So kilopascal it says, so I'm going to convert it here itself by multiplying it times 10 to the power 3 so that I will remember to do that later. So what is the cross-sectional area of the cylinder? So they have given me force, they have given me the stress, 130 times 10 to the power 3 Pascal, and they're asking me area, which is a simple question. So if we know that there is an equation that connects all the three of them, and that is stress is equal to force over area. So area is equal to force divided by stress, 7.8 divided by 130 times 10 to the power 3, and we end up getting 6 times 10 to the power minus 5. So our answer is B. Okay, now here if you don't convert the kilopascals into pascals, you will end up getting the first one and you will go wrong. Moving on, question 7 is about wavelength and temperature, which comes under the first topic of cosmology, which we have not done. This is a question from Wien's displacement law. Since we have not done that, we are skipping question number 7, so that's why I put a cross there, and we are moving on to question 8. Okay, so the object shows two opposite vertical forces of magnitude 1.2 and 2.1 Newton acting on the object. Which of the following statements could be correct? So you have a 2.1 Newton acting upwards and 1.2 Newton acting downwards. So we can easily calculate the resultant force, which is 2.1 minus 1.2, 0.9 Newton upwards. So that is our resultant force. So which of the following statements could be correct? The object is accelerating and moving up. Yeah, so if it is moving up, it is accelerating, definitely, because it is moving in the direction of the resultant force. The object is decelerating and moving down. So the resultant force is upwards, as you can see here, and if the object is moving down, then it means that the object is moving in the opposite direction of the resultant force. So that will make the object to decelerate. So this bit is also correct. The magnitude of the resultant force is 0.9 Newton, that in which we have already worked it out, which means all the three options are correct. So our answer will be D. Options 1, 2 and 3 are correct. Okay, now we are moving on to question 9. This question is a bit confusing. The first time I read it, anyway, I found it a bit confusing. Maybe you guys might not. You guys have young brains, isn't it? Graph of y against r from the center of a planet is shown below. So this is some physical quantity y. They are not telling us which one it is because we have to identify that one. And even though they have given us a graph of y and r, they are saying that from this you can make out that y is inversely proportional to r square. Okay, so this is the graph of y against r. From this we can easily show that y, and if you take a graph of y and r square, not r, it's going to be inversely proportional. Inversely proportional will look somewhat like this, but it will have a steeper gradient. Okay, then so which quantity is best represented by the y on the y-axis of the graph? So don't worry too much about the shape of the graphs, just think about which are the two quantities that we know, or which is the quantity that we know which is inversely proportional to r square. So the first option they have given us is period of satellite orbiting the planet. So if you think about Kepler's third law, it says that t square is proportional to r cube. So it is not r square, it is a relation between t square and r cube. So it's not this one. Gravitational potential of a planet, if you think about the equation, it is an equation where it tells that the potential is directly proportional to the mass and inversely proportional to the distance. So again, it's not r, it is not r square, it is r. But if you think about gravitational field strength is directly proportional to the mass and inversely proportional to the square of the distance. So our answer is C. Now we are moving on to the next question. So question number 10 is about the line spectra, which again we have not done yet. So we are skipping that one and we are moving on to question 11. Tensile force of 4.5 Newton and it extends elastically by 3.2 centimeters. So times 10 to the power minus 2 meter. What is the potential energy of the spring? So we have been given the force, we have been given the extension. Again, that is very simple, easy question. If we know the force and extension, then the potential energy is given by half Fx. So half times 4.5 times x is 3.2 times 10 to the power minus 2 meter. And you end up getting 0.072 joules. Okay, so that tells us that the answer is A. Clear? It was a simple question. Then let's move on to question 12. Okay. An object above the ground is released from rest at time t is equal to 0. So it is released from rest. So what does that tell you? It tells you that u is equal to 0. Calculate the distance traveled between objects by the object between t is equal to 0.2 seconds and t is equal to 0.3 seconds. And then it has been released from rest from above the ground. So it tells us that the value of g or value of A is same as the value of g, which is 9.81 meters per second square. Anyone wants to use 9.8, not 81? Go for it, no problem. So we have to find the distance traveled, which is s. So normally when we have to link s with u, t and g, the equation we use is s is equal to ut plus half at square, free fall, at becomes gt. U is 0, so this term vanishes. So you can find out what is the distance traveled when the time is 0.2 seconds, and then find out the distance traveled for the time of 0.3 seconds, and then between these two you just need to subtract them. So half times 9.81 times 0.3 square minus 0.2 square. So if you work it out, it turns out to be